Good morning, class. We are looking at application of trigonometric functions. Section 5.4, right triangle trigonometry. And in this section, we are going to cover solving right triangles and solving applications. So we've already covered recalling properties of trigonometric functions and fundamental identities, double angle, half angle summaries. And as far as a right triangle is concerned, a squared plus b squared is equal to c squared, a plus b is 90 degrees. And then the definition for sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is opposite over the adjacent. And the rest of them are the reciprocals. For example, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotangent is the reciprocal of tangent. And we started looking at some examples here. Solving a triangle means find three sides, three angles, and we did that with several examples here. We also went over cofunction or complementary angles. Sine and cosine are considered cofunctions if their angles are complementary. Tangent and cotangent, secant and cosecant. Then we looked at several application problems. Angle of elevation. The line of sight with respect to the horizontal line. If the object is above the horizontal line, is considered angle of elevation. If it's below the horizontal line, it's considered the angle of depression. We looked at examples of that. And in this case, we were calculating the difference in the height of the building and the height of the building plus the statue. And the difference between the two proved to be fairly straightforward. And that was the answer we were looking for. So we're going to move on with the new stuff. Here's example 8. A bearing is used to represent the direction of one point relative to another point. Method 1. The direction or bearing of a point is the number of degrees in the angle measured in a clockwise direction from the north, the vertical line, to the line joining the center of the compass with the point. Method 2, direction or bearing of a point O to point P equals the acute angle theta between the ray OP, for example, this one, and the vertical line through O, the north-south. In short, we either start with north or south, and then the closest angle. For example, we want to look at these values, P1, and they are giving us this 30-degree angle. So we always start with north or south. This is the acute angle meaning between 0 and 90 degrees. So north 30 degrees, and P1 is to the right of it, east. P2. P2 is closer to the south. So we start with the south. Then the angle is 50 degrees. And now P2 is to the left of it. That means west. S, 50 degrees west. P3 is closer to the north. So we start with the north. It makes a 70-degree angles to the left of it. So north, 70-degree angles. Which side? West. P4 is closer to the south. So south, what's the angle? 20 degrees. Which side? To the right, east. So south, 20 degrees east. That is method 2, which is used more often. For method 1, we just look at this north side and we go this way, clockwise. So this angle is 30 degrees. So P1 is just this number, 30 degrees. Okay. So we have all those answers that was mentioned here. And the P4. So for method 1, this is 30 degrees. Done. For P sub 2, P2, P2 is here. So from the north, we are interested in this angle, clockwise, this angle. So as you can see, this gives you 180 degrees. Plus 50 gives you 230. I want to make sure we understand what's going on. Let me do the drawing for you. So we are interested in this angle. And this is 180 plus 50. I should have gone with the green. All right. Now P3 is this angle. And this is 180 plus this angle, which is 90 minus 70. This is, my apologies, 270. I said 270. So this angle is 270 plus 90 minus 70, 20, and makes it 290 degrees. Let me again explain it to you with the laser. So this is 180 degrees. This is 270 degrees. We need to add this much. We know that this is 90 degrees, and if this is 70, this must be 20. That's why, everybody, this angle, 270 degrees, plus this little one, which is 90 minus 70 or 20, and that gives us a total of 290 degrees. Now, P4. I go over the red one. P4 is this angle. P4 is this angle. So this is 90 degrees. How much is this one? From here to here is also 90 degrees. So if you subtract 20, or you can say this whole thing is 180 degrees, subtract 20, this much, this little one is 20. So from here to here is 180. Take away 20 degrees and it gets 160 degrees. Could somebody read this question, please?
I can read it if you want.
Please.
Okay. An airplane takes off from a runway which has a bearing of north 20 degrees east. It flies for 1 mile and then the pilot requests permission from the control tower and turns 90 degrees heading towards the northwest. After the plane goes 2 miles in this direction, what bearing should the control tower use to locate the aircraft?
Excellent. So let's draw the setting. North, south, west, east. So north, 20 degrees east. So this is north. East is to the right of north by 20 degrees. So this is the heading, 20 degrees, and we cover 1 mile. We cover 1 mile in this direction. Then we're going to make a 90-degree angle here towards northwest. So the 90-degree angle that we make here, we can go this way or that way. Okay, so we make a 90-degree angle. But we are going this way because it says northwest. Okay, so when you make a 90-degree angle here, you can go either way. It is telling you which side. And we're going to go for how long? 2 miles. So this way 1 mile, this way 2 miles, this is a 90-degree angle, this is a 20-degree angle. So we are going to connect this point, we call it OQ. So from OQ, O2Q, we see we want the bearing, right? We want the bearing. So the bearing is north, this angle, and west. So if you call this angle alpha, the bearing is north, alpha, west, north, alpha, west. What is alpha? This whole thing is called theta. Then alpha is theta minus 20. So the bearing from O to Q is north alpha, west. How do you find alpha? This total angle, we call it theta minus 20 degrees. And as you can see in this triangle of POQ, tan of theta is the opposite PQ over the adjacent OP, resulting in 2/1 or simply 2. 2/1 or simply 2. So what is theta? Tan inverse of 2. Using a calculator results in 63.4 degrees. But we want alpha, and we said alpha is theta minus 20. Alpha is theta minus 20. Subtract 20 degrees from that, and you get 43.4. So we have north 43.4 degrees west. Okay, it's very straightforward, everybody. A security camera is mounted on a wall 9 feet above the floor. What angle of depression should be used if the camera is to be directed to a spot 6 feet above the floor and 12 feet from the wall? We have to draw the setting. So this is 9 feet. We are going to have the camera 12 feet above the floor and 12 feet from the wall. So this distance is 12 feet. Camera is here. Okay. So camera is here. And this is 9 feet. Now this is 6. The camera is supposed to be directed to a spot 6 feet above the floor. So it's going to be looking at this point, creating this distance of 6 feet. So this must be 9 minus 6 or 3 feet. So draw the setting. Draw the setting, everybody. Well, then A is the opposite, which is 3, over the adjacent, which is 12. A is tan inverse of 3 over 12, which is 1/4. So let me write this. This is 1/4. And using a calculator, we get almost 14 degrees. Drawing the setting is extremely important, everybody.
I have a question for this one.
Of course.
Will there be word problems like this on the test, on the next test?
I hope so.
Yeah, just because the interpretation of the question is a little bit confusing, I think, when it's
Um,
to be like 6 foot above the floor but 12 feet from the wall. Because I thought it meant like the camera has to be 6 feet above the floor.
a security camera is mounted on a wall 9 feet above the floor. So that means 9 feet above the floor. So this is the floor.
Okay.
So 9 feet above the floor. When it says above the floor, somewhere here,
Oh,
and
so
it's
that is
12 feet from the wall. So it's somewhere here, 12 feet from the wall. So this distance is 12 feet. So it's precisely giving us the location of a camera is this corner, where at this point, we have the distance of 12 feet from the wall and 9 feet from the ground. I think it's
oh,
pretty clear.
okay. I think I just read it too quickly.
No worries, no worries. Well, why don't you read this one for us, please?
Uh-oh. Okay. A straight trail with an inclination of 17 degrees leads a cottage of an elevation of 9,000 feet to a mountain peak at an elevation of 11,200 feet. Find the length of the trail.
Okay, we try to uh, draw the setting, okay? We try this, and so there is a trail. The inclination of 17 degrees. This is the length we are hoping to find, okay? The cottage at an elevation of 9,000 feet. So if the cottage is here, it's at 9,000 feet of elevation. This distance is of interest to us, where we know if we call the very top A and the very bottom B, this distance gives us the total elevation of 11,200 feet. That's the setup. In many cases, you do have the picture. In some cases, you have to come up with your own drawing. So after we come up with that, clearly this would be the difference between these two numbers. So now that we have this distance, which is 2,200 feet, we want to find the length of the x. Sine of 17 degrees is the opposite over the hypotenuse. The opposite is the question mark, which we found it to be 2,200 feet. And the hypotenuse is the missing x. As you can see, it's a proportion. You can interchange x and sine of 17 degrees. So you could write, so right here, you could write x is 2,200 divided by sine of 17 degrees, at which point we use a calculator. I'm going to put a few decimals, and all of them are approximations. Normally, they ask for one, maybe two decimals, okay? So the hardest part, believe it or not, is the drawing. That's why when you want to do this, you want to read it a couple of times. Find the inclination or the grade of the trail. So what are we looking for? We are looking to find B. That's the question. The angle B. Well, if you look at this triangle, sine of a B is the opposite, which is 3,100, over the hypotenuse, which is 14,100. And we can drop the two zeros. We can drop the two zeros. So B becomes sine inverse of this number, meaning you use a calculator. And however many decimals, this obviously has many decimals, as you can see from the calculator. Let's say we go with 1, 12.7 degrees. Even if you go with 2 is 0, but if you go with this one class, this must change to 1 because next to it is 7. Okay, so however many decimals. Normally with the degrees, we don't go too far. Could somebody read this, please?
A visitor at the top of the Gateway Arch, height 630 feet, in St. Louis, Missouri, observes a boat moored on the Illinois side of the Mississippi River, 2,070 feet, directly across from the arch. She also observed a boat moored on the Missouri side, directly across from the first boat. Given that B is equal to cotangent,
Inverse.
sorry, negative inverse, right? 67/55. Estimate the width of the Mississippi River at the South Louis Riverfront.
Excellent. Thank you so much. So let's see what is given, what is missing. So we have this distance of 630 feet. We have this distance of 2070 feet. And if we call this distance, everybody, this one, X amount, we want to estimate the width of the river. We want to estimate what? This distance, which is what? 2070 minus X. So again, just to recap, we have this distance, 630. We have this distance, 2070. We don't have this distance, we call it X. If we find this distance, the river has a width of total of 2070 minus X. That's what we are looking for. That's the first thing, understanding the concept. This angle is called A, this angle called B, and we know B, we have this as cotangent inverse of 67/55 precisely. You can put it in the calculator to see what, how many degrees. But for now, this whole thing is A plus B, everybody. This whole thing is A plus B. Okay. And I can find the tangent of this whole thing A plus B because it's the opposite, which is 2070 feet, over the adjacent, which I have it to be 630. So we can find the total angle here using this formula. So what is A plus B? Is the tan inverse of this. Now later on, we're going to use the calculator to come up with the answer. Of course, you can drop a 0 here. In order to find X, we need the little angle A. In order to find A, over here, we're going to say, whatever this number is, which we don't have, minus B. Now, class, tan inverse, remember, this is an angle. Subtract from it angle B, you get angle A. I hope everybody's clear on that. And we're going to replace the B with cotangent because B is not missing. B is given. B is given. We're going to replace it. All you have to do at this point, use a calculator and find the angle A. We're going to move on to find X. So using a calculator, notice I dropped the zeros, one from the top, one from the bottom. Okay. So tan inverse of this is 73.07. Now, tan inverse, notice what I did here. Remember, cotangent for the inverse function goes from 0 to pi, so you got to be very careful. If it's positive, you can use the tangent. How? I put the tan inverse and I put the reciprocal of this number, 55/67. This is the same as cotangent inverse. However, if it's not in the first quadrant, remember, because it goes from 0 to pi, tan inverse will not do it because tan inverse goes from the fourth quadrant to the first quadrant, from minus pi over 2 to pi over 2. So you want to be very careful when you calculate that. Both of them are positive, and both of them are in the first quadrant. Both of them are from 0 to pi over 2. That creates no problem. And therefore, the difference between these two, see this minus that, there's not enough room to show that, is 33.69. So we got the angle A. And now that we have that, clearly tan of A, the blue one, is the opposite X over the adjacent 630. So X is the product of these two, right? X is the product of 630 and tan A. And it gives you about 420 feet. Notice everything is an approximation class, and they are going to go with feet, so we're going to stick with that. You can go with 1 decimal and then make a decision. So if you know X, what is the width? We were looking for this number, 27D minus X. 27D minus X. X is 420. So the width of the river, it must be 1,650 feet, roughly. Could somebody read this question, please?
The Gibb Hills Lighthouse, Southampton, Bermuda, in operation since 1846, stands 117 feet high on a hill 245 feet high, so its beams of light is 362 feet above sea level. A brochure states that the light itself can be seen on the horizon about 26 miles distant. Verify the accuracy of this statement. Earth radius r equals 3,960 miles and 1 mile equals 5,280 feet.
Perfect. Excellent. Thanks. So what is it that we want to find? It says that the brochure states that the light itself can be seen on the horizon above about 26 miles. So that means what? If we are here, here's the light. So 26 miles, that's what they are claiming. So what are we looking for to verify that? We are looking for this distance S equals r theta. We are looking for this distance S, the arc length, which is r theta. R theta. That's what we are looking for. So we are looking to find theta. And to find theta, if you look at this triangle, okay, cosine theta would be this distance, the adjacent, this distance, 3960, over this distance, the hypotenuse, which is the sum of the radius of the earth and 362 feet. So again, this is blown out of the proportion so we can see that. What is cosine of theta? Cosine of theta is the adjacent over the hypotenuse. The adjacent is 3960 miles. The hypotenuse is 3960 miles plus 362 feet. Now we have to change everything to miles or feet. It's easier to keep it as miles. This is 3960. This is 3960 plus 362 divided by 3960. So cosine theta is the adjacent over the hypotenuse. The adjacent is 3960, okay? And that is 3960 miles plus, and the denominator, the hypotenuse is 3960 plus 362 feet. In order to have the same units as miles, we're going to divide that by 5280. I hope everybody understands the concept of a conversion. You put it into a calculator and you have to use a lot of decimals because this is almost 1. Okay, we don't want that. So many decimals, 0.9998267. And theta is the cosine inverse of this number. Using a calculator, we get 0.33715 degrees. And then We want to find S equals R theta. By the way, class, this is degrees, this is minutes, okay? Normally, if it's a fraction of degrees, we represent it with minutes. If you recall, 1 degree is what? 60 minutes. 1 minute is 60 seconds. So 0.33715 degrees, 0.3 degrees roughly, or 20.23 minutes. Now, we are going to multiply this by pi 1/1/80 to change it to a radian. Why is that? Because S equals R theta. Theta must be in radians. R is 3960. Theta is what we found here in radians. Resulting in 23.3 miles. But they claim what? 26 miles. So clearly it's an overstated statement. Okay. So it's very straightforward that it's way, the claim is incorrect. It's way too much. Find the angle of elevation of the sun if at 10 a.m. on April 26, 2000, a building 300 feet high cast a shadow 50 feet long. So here's 50, here's 300, and this represents the direction towards the sun. This represents the angle of elevation. Okay, tan of A is the opposite over the adjacent 50. Okay, it's the adjacent. It's the opposite over the adjacent, 300 over 50. Which is 6, and A is tan inverse of that, and putting it into a calculator results in 80.5 degrees, 80.5 degrees. Could somebody read this, please?
A laser beam is to be directed through a small hole in the center of a circle of radius 10 feet. The origin of the beam is 35 feet from the circle. At what angle of elevation should the beam be aimed to ensure that it goes through the hole?
Excellent. So what we have here is this distance of 35 feet from the circle. So we wanted to go through the center, and the radius is 10 feet. So we have to create this angle, theta. You can think of it as angle of elevation. Clearly, tan of theta is the opposite, 10 feet over the adjacent 35 feet. So we are interested in tan of theta because those are the numbers given. 10 over 35. Therefore, theta is tan inverse of this number. Needless to say, it can be simplified, class. So everybody knows that I can get rid of the 5 and I make this 2 and I can make this 7. So tan inverse of 2 over 7. We know that, okay? So tan inverse of 2 over 7 using a calculator results in 15.9 degrees. 15.9 degrees. Could somebody read this, please?
The ship leaves the port of Miami with a bearing of south 80 degrees east and a speed of 15 knots. After 1 hour, the ship turned 90 degrees towards the south. After 2 hours, maintaining the same speed, what is the bearing to the ship from port?
Excellent. Well, let's see what we have to do. Again, here's the drawing, okay? M represents the location for Miami. So a ship leaves the port at a bearing of south 80 degrees east. So from the south, go to the right and make an 80-degree angle. With a speed of 15 knots. After 1 hour, the ship turns 90 degrees. So this is the 90 degrees. Can go either way. So it can go up or down, but goes towards south. So it goes towards south. So this angle is 80 degrees, everybody. This is 90 degrees. So we've gone this far to some point, let's say A, after 1 hour with this speed. And we are going this way after 2 hours. And we connect it. So we go this way 1 hour, we go this way 2 hours. Okay. We want to find the bearing of the ship with respect to the port. Okay, with respect to the port M. So what is it that we are looking for, class? If you call this point B, if you call this angle theta, then the bearing is what? South. Theta, whatever it might be, we don't know yet. To the right of it, east. So we are looking for south, theta, east. That's what we are looking for. So what do? We know this entire angle is 80 degrees. This entire angle is 80 degrees. If we could find this little one, which we are going to call angle AMB, AMB. If we could find the yellow one. All we have to do is subtract it from the entire 80 degrees to get the green one theta. Okay, that's the idea. Well, we can find that tan of this yellow one, or AMB, the angle AMB, is the opposite AB over the adjacent AM. AB is 2 times 15. AM is 1 times 15, right, everybody? Please understand why 2 times 15, 1 times 15. Those are the speed. And so it's simply 2. Tan inverse of 2 is 63.4 degrees. And theta is 80 minus that number, 63.4 degrees, which gives us 16.6 degrees. And so now replace the theta, and the bearing becomes south, 16.6 degrees east. So that's the speed. It's a little bit more than a mile. It's about 1.15 miles per hour, 1.15 mile per hour. So that's the meaning of that. Here's the last question. Could somebody read this for us? Anybody? Last question. Let's go.
A camera is
Continue, please.
a camera is mounted on a tripod 4 feet high at a distance of 10 feet from George, who is 6 feet tall. Camera lens has an angle of depression and elevation of 20 degrees. Will George's feet and head be seen by the lens? If not, how far back would the camera need to move to include George's feet and head?
Excellent. Thanks. So here's 4 feet. Here's the angle of elevation, 20 degrees, depression, 20 degrees. George is 6 feet tall. Okay. And this is 10 feet. So never mind 10 feet. Okay. What distance is required? So head to toe will be covered by the camera. So let the required distance be X. Again, this is 10, but maybe we have to go further and we make it more or get it smaller. So the actual distance we need is may or may not be 10. So we're going to call the actual distance X. And we're going to deal with that X. This is 4 feet, everybody. So if we go down here, this is 4 feet and this is 2 feet. So this one is a 4, this one is 2, because this is 4 feet. This distance, okay, all the way to the George's feet is 4 feet. To the George's head is 6 minus 4, or 2 feet. So tan of 20 degrees, if we look at this one, okay, tan of 20 degrees is the opposite, which is a 4 divided by X. Therefore, X and tan 20 can interchange because of the nature of the proportion, everybody. This is over 1, their cross product. So it's the same as saying X. This is from basic algebra. You can interchange those two. X is 4 over tan of 20. And of course, you put it into a calculator, you get 10.99, but 11 feet. That means 10 feet is not good. We need how much? Almost 11 feet. Therefore, the camera has to move. So this is not good. The camera has to move back by almost a foot. We need almost 11 feet, but we have 10. So this has to go back by 1 foot.
I have